Welcome to a lesson on division of polynomials. In this lesson, we will only be discussing division by a monomial. To divide a polynomial by a monomial, we divide each term in the numerator by the denominator, then simplify each expression. So for example, if we have the quantity a plus b divided by c, this is equal to a divided by c plus b divided by c. And let's verify this actually works. If we let a equal 1, b equal 2, and c equals 3, we would have this expression here. If we simplify this using the order of operations, there would be implied parentheses around the numerator here, so we'd find this sum first. 1 plus 2 equals 3, so this simplifies to 3 divided by 3, which equals 1. But now if we apply the property we're going to use when dividing by a monomial, we would divide each term in the numerator by the denominator. So here we'd have 1 divided by 3 plus 2 divided by 3, or 1/3 plus 2/3, which equals 3/3, which also simplifies to 1. So when dividing by a monomial, it is valid to divide each term in the numerator by the denominator. So going back to our examples, we're asked to simplify the following expressions and write the answer with only positive exponents. Notice example 1 is just a monomial divided by a monomial, and since we already have a single fraction here, to simplify this, we just simplify the fraction. So we simplify the coefficients, and then we simplify the w's. We'll notice that 6 and 30 share a common factor of 6. There's 1 6 and 6 and 5 6 and 30. So our coefficient would be negative 1/5. And then we have w to the 8th divided by w to the 3rd. We're dividing, the bases are the same, so we subtract the exponents. We would have w raised to the power of 8 minus 3. So our simplified expression is negative 1/5 w to the 5th. So this is our simplified expression, but I also want to show how we can express this in a slightly different form. Negative 1/5 w to the 5th is equivalent to negative 1/5 times w to the 5th over 1. In this form, we'd have negative 1 w to the 5th over 5. Of course, the 1 here is optional, so this would be equal to negative w to the 5th divided by 5. Either of these two expressions are acceptable for the simplified expression. Example 2, we have the quantity 3x minus 6 divided by 2. Again, we're dividing by a monomial, so we divide each term in the numerator by the denominator. So we'd have 3x divided by 2 minus 6 divided by 2. Well, notice 3x divided by 2 doesn't simplify. There are no common factors between the numerator and denominator. But here, 6 divided by 2 equals 3, so we can write this as 3x divided by 2 minus 3. So this is one way to express our quotient, but notice how this first term would have a coefficient of 3/2. So we can also express this as 3/2 x rather than 3x divided by 2, and then of course minus 3. Both of these expressions are acceptable. Example 3, we have a trinomial divided by a monomial. So in this case, we'll have three fractions to simplify. First, we'll have 6x cubed divided by 4x. Then we'll have plus 2x squared divided by 4x. And then finally, we have minus 4 divided by 4x. Remember, the exponent on x is 1, here, here, and here. So now we'll simplify each fraction. Notice for the first fraction, 6 and 4 share a common factor of 2. There are 3 2's in 6 and 2 2's in 4. So we'd have 3/2, and then we have x to the 3rd divided by x to the 1st. That would be x raised to the power of 3 minus 1, plus 2/4 simplifies to 1/2, or we have a common factor of 2. There's 1 2 and 2, and 2 2's in 4. So we have plus 1/2. We have x to the 2nd divided by x to the 1st. That would be x raised to the power of 2 minus 1. And finally, for the last fraction, we have minus. Well, 4 divided by 4 is equal to 1. Well, we have a common factor of 4. It's 1 4 and 4, and 1 4 and 4. So notice how this last fraction simplifies to a numerator of 1 and a denominator of 1x or just x. Remember, we are asked to express this only using positive exponents, so there's no reason to write this as x raised to the power of -1. So here we have 3/2 x to the second plus 1/2 x, then again -1 divided by x. This would be our simplified quotient, which we could also express here as 3x squared divided by 2 plus, here we could write this as 1 times x over 2, or just x over 2, minus 1 over x. Either of these forms are acceptable. In our last example, we have another trinomial divided by a monomial. So we'll have three separate fractions. Our first fraction will be 20a squared divided by -5a squared. And then we have plus 35a divided by -5a squared. And then finally we have -4 divided by -5a squared. The exponent on this a here would be 1. So now simplifying the first fraction, notice how here we have 20 divided by -5, which simplifies perfectly to -4. And then we have a squared divided by a squared. Anything divided by itself is equal to 1, but applying our division property of exponents, we'd have a raised to the power of 2 minus 2, plus, here we have 35 divided by -5, which is equal to -7. So we have -7, and then we have a to the first divided by a to the second. That'd be a raised to the power of 1 minus 2. And then finally here we have, now for our last fraction, notice how we have minus and negative, which is the same as adding a positive, so we'd have plus 4/5 doesn't simplify. Notice how we also have a squared in the denominator. Let's go ahead and simplify again. Here we have -4. This would be a to the 0, but a to the 0 is equal to 1, so this is just -4. Now here we have plus -7 times a to the -1. Adding a negative is the same as subtracting a positive, so this is -7a raised to the power of -1, and then we have plus 4 divided by 5a squared. But notice here we have a negative exponent, so if we put this in fraction form, we would move the a to the -1 down to the denominator, which would change the sign of the exponent. So our final quotient will be -4 minus 7 divided by a plus 4 divided by 5a squared. This would be our simplified quotient. Okay, I hope you found this helpful.